This is page 4 of the Chapter 2 activity. I have pulled up the answer key, and on question 4, this is a very simple and short frequency table. It just shows that there are two people that have a height of 61 inches, two with heights of 62 inches, one with height of 63, and a whole bunch of people, 9, with a height of 64 inches. In order to find the mean from a frequency table, you can't just add up the heights and divide by 4 because there are actually 14 people in this table. So you could do 61 plus 61 plus 62 plus 62 plus 63 plus a whole bunch of 64s. And what I show you in this formula that looks maybe a little intimidating is that you multiply each x value or each data value by its frequency. So the data value 61 times its frequency 2 plus 62 times 2 plus 63 times 1 plus 64 times 9, and then divide it by n, the total of all the frequencies, which is 14. So you're going to get 885 divided by 14, or 63.2 inches for the average height from that frequency table. Now, sometimes we have a grouped frequency table. This is example 15. And we're like, well, which number would we multiply by the frequency? So if you do not have an actual weight, you have a range of values, you use the midpoint of the interval. And to find that midpoint, I guess you could do mental math, but I do 70 plus 130, and then divide by 2. And I did that again for the next one, 130 plus 190, divide by 2, and so on. So I wrote down the midpoints of each interval, and that is your m, and you multiply by the frequency. So 100 times 5, 160 times 4, and so on. Once I have that total, I can divide by 12, and I get 155 grams as the average potato weight. Notice that this is sort of a rough estimate because we didn't have the actual data, we just had the grouped frequencies. But if we look back at our potato weights, we actually got 154.1, so that's pretty close to what the actual answer was. The next part of this is to, let's see if I can get this to scroll. There we go. Can we do this process on the calculator? So I'm going to press clear, and then I'm going to press stat, and then enter for edit. And I'm going to enter the data from problem 14 into L4 and L5 on your calculator. So right now I already have data in L1 through L3. So I arrow over, and then I'm going to get that data from up here. And I'm going to put this data, these 4 numbers, into L4. There's the L4, and here's where the L5 data is. Okay, so and then I arrow over 2, 2, 1, 9. And by the way, if you accidentally put in too much data, you can arrow up and press delete. The two lists should be the same length. And then let's continue here with the instructions. If you need to clear data from a list, arrow up onto the L4 and press clear, and then arrow back down. I can just show you that. Like if we had some junky data in here that we didn't want, I can arrow up on top of the L6, press clear, and you're like, it didn't go away, but then you arrow down and it's gone. So Okay, so let's go here. We can find the mean and more using one variable stat. So stat calc 1, one variable stats, and then where's my list? My list is in second L4, and the frequency list is second L5, and then I can tell it to calculate, and it calculates 63.2, which is what we had gotten here. So that's cool. And the way I'm showing you in this diagram is the TI-84 that is not a plus. So the old school TI-84 requires you to, once you hit one variable stats and you tell it this information, this pops up on the screen, and you have to do second L4, comma, second L5, and then press enter. And that one variable stats command comes up, and then the result that you see over here should be the same. So just showing you that different calculators may behave differently. And if you have issues, feel free to check in with me or go to the STEM Learning Zone and they can help you. So the sample mean x bar was 63.2. Sigma x, okay, so this symbol is the capital S, Greek letter S, sigma, and we will also learn that there's a lowercase letter s, which is also sigma, and again, it looks sort of like an O with a tail on it. This sigma is the capital S, and it's used to mean add them all up. So add up all your x's and you get 885. Divide by n and you get divide by 14, and that's how we got the 63.2. All right, and then let's just talk a little bit about standard deviation. S is a measure of the variability of a set of data. The sample standard deviation will always be slightly bigger than the population standard deviation. So sample standard deviation from this data set, so if we look up here, we can see that there is a sample standard deviation of 1.188, or close to 1.2 inches, because we were talking about height. And the population standard deviation, sigma, was 1.145, or about 1.1 inches. And we'll get into these a lot more as the course progresses. So this is sort of an introduction in the variation or the standard deviation of that height data. And if you hear somebody talking about variance, the sample variance is just S squared. And the population variance is the square of the population standard deviation, sigma squared.